Okay, so for this particular problem, we've got, of course, potentially a new major being offered. 2,000 students were included in a simple random sample, and 532 were returned. Of those, 219 supporting the new major. Lots of information in here, but the question is actually very basic. Which of the following represents the population for this study? So this really comes down to um, recognizing some of this information isn't necessary. So when we're wishes to poll, okay, sorry, I'm kind of not speaking clearly, but if we're trying to figure out the population, let's go back to kind of the setup. The university is considering introducing a new major and wishes to poll the current student body for their opinion. So right there, it tells you that the current student body is the population. So if we look here, okay, it's not the students who received the questionnaire. It's not the 532 who responded. It's not the 219. So the only good option so far is 2,000 selected represent a sample of the population of all currently enrolled students. And last one says all who are currently enrolled and all past alumni of the school. So it's not the alumni that they're including. So D is the answer here, which was the choice for just under half of you. I do have a second bell work problem for you, which won't take as long to read through. Okay, so let's look at this real quick. We've got, as far as this goes, a company is wishing to market a new product and they are randomly selecting from their customer database. Now, we could go through and kind of think through it, but really what this comes down to is this is a convenience sample. And a few of you got that, right? So it's convenience because the population of interest is all consumers, not just their current customers. So they're going to market this to everyone. And if that's the case, you need to poll, you need to sample from everyone. And they did it the lazy way. They just went to their customer database. So if they had randomly selected the population, yeah, it could have been potentially a simple random. But there we go, convenience survey for this one. Okay, so as far as this goes, there are some things that are important for you guys to understand. And I'll just kind of show these real quick. And then I'm going to go over to the Canvas page real quick to explain some things. So you need to sign up for the AP Classroom if you haven't done that yet. There's about 5 or 6 in this class who have not done that, or at least you hadn't last night when I checked. It's required for the class because there's things I assign there, but if you want to take the AP test in the spring, you must be signed up. So it's required no matter what, but especially for the AP test. Okay, the AP contract and the 4-year plan, I'm going to show you what you need to do exactly with that because I still get questions about it and a lot of people haven't turned it in or done it or let me know they've done it. Anyways, in the progress check, that is just a reminder that that needs to be done. And so we're going to go over real quick to the Canvas page, which I don't have pulled up yet, so I'll do that. And again, because I keep getting questions about the, didn't want that, sorry. I keep getting questions about the AP contract. I thought it would be worthwhile showing. A lot of you have already done this, so you don't need to see it. I'm going to try and do it very briefly. So we've got, well, actually, the first thing I want to say, it started this week, but we were working out the kinks. But starting next week, I guess we can say, during that intervention time advisement class period, Monday, Tuesday, Thursday, Friday, when there's nothing else going on, if you need help with stats, this link right here, it's IP tutoring link. You want to come to the Canvas page, click on that, it'll take you into that meeting. You won't necessarily see me, but there'll be someone there. You can say, I'm here for stats help, and they can send you to my breakout room. So if you have stats questions, that is a fantastic time. You don't need to schedule that, just show up. The other stuff here, the AP documents that I keep talking about you need to fill out are located here. If you didn't see that, was up at the top. I'll go back in a minute. The actual AP contract form and for your agreement are these links right here. This is just a link to see what the expectations are, but it's not what you actually fill out. So make sure you go here, fill both of these out. When you do that, you're not done because I don't know that you have actually turned anything in. It doesn't come to me. So you would have gone here to link to your AP documents, but then you have to go down to Unit 3. It's in Unit 3 because that's when I assigned it. This right here, turn in AP documents. Anything that's indented is an assignment that needs to be turned in. So you would come over here and you can click on that and you'll see that there's a submit an assignment. If you do that, it's just a Word doc. All you need to do is, or just a little text box, all you need to do is say, done. That's it, submit it. And that lets me know, okay, they took care of doing that. So if you have turned that stuff in, it should take you about a minute to turn that text document, that text box in. Okay, so the next one, the progress check, that's done on AP Classroom. When you sign in, you should have a link to certain assessments, and one of them is a progress check. When you have done parts A and B, and you can, anyways, when you're done with that, this is another thing. You just need to submit an assignment that says, I'm done. So that is my way of knowing, okay, they finished, they're good to go. I'm trying to think if there's anything else of note that we need to talk about here. Oh yeah, the classroom codes. So the progress checks, of course, require you going to the AP Classroom. But if you have not signed up for the AP Classroom, this is how you do that. You would scroll down here to 7th period, just so you can see this code. You have to go to myap.collegeboard.org. You need to create an account if you don't already have one for a different class. And once you've got an account, you would just put this code in and you will join the AP Stats class. You do need to be part of it. Here's the code you need to get that done. Okay, so again, just to show one last time where I got that, under Resources and Support, you have your AP documents and classroom codes. And that is that. I think that's everything that needs to be mentioned. Okay, so now we are going to pass this stuff. We're going to talk just about a little bit of Chapter 13. So when we're going to be talking about Chapter 13 today and on Monday, and I had an option of whether to do like half of it today, half of it on Monday, and I opted to do very little of it today so that we could leave early, and the rest of it on Monday. So Monday will be a packed day, but hopefully today we can get out quickly. We're just going to talk about observational studies. You don't have homework from the book tonight. So experiments make up the bulk of Chapter 13, but observational studies are really important. And the key difference is that in an experiment, you randomly assign people to a treatment. In an observational study, that is not the case. You're observing things that have happened in the past or in the future, and we'll talk about that. But you're observing results just from life, basically. So hopefully that makes sense. So we're going to come back to this example a few times, but in July 2020, the Henry Ford Health System released a study that showed that hydroxychloroquine reduced the death rates of COVID-19 by half. That was an observational study, and we're going to talk about it a little more on the next page. But it looked at patients treated at a clinic over the course of 2 months who were not randomly assigned that treatment. So observational studies come in 2 flavors. We've got the retrospective study. So these are past events that have already been recorded. The outcome is known, and you can kind of consider that past data in your study. The hydroxychloroquine study was a retrospective study since it looked at outcomes from past patients. A prospective study is basically saying, I've selected my subjects and now we're going to see what events unfold in the future. And, you know, there can be all kinds of reasons for doing things like that. A lot of times maybe you're going to follow young children through their life and you're picking them at a young age. Maybe, and this is just one example, maybe you want to see what happens to babies who are born with fetal alcohol syndrome. and you want to now say, okay, here's some babies who are born with this. I'm just going to follow them and see how events unfold in their life. And so that'd be a prospective study. Now, neither one of those has any kind of controls for other variables. Or, they're not set up as an experiment is. Let's just say that. And we'll talk about that more today and, of course, on Monday. So observational studies are subject to a number of factors that limit their usefulness. So they are subject to confounding variables. So we can never use observational studies to say that there is a causal relationship between any variables. So going back to the hydroxychloroquine, we can't say that that caused death rates to go down because there were confounding variables. Some of those patients that got hydroxychloroquine were also given steroids. So it can't be confirmed whether it was due to the hydroxychloroquine or steroids or some other factor. There could have been all kinds of things. It was not a controlled experiment. It was just an observation. Both types, but especially retrospective studies, are subject to flaws in the data. So if you go far enough back in time, you can imagine there's a lot of death reports that aren't very accurate. So it could have just said natural causes, and maybe it was cancer. Maybe it was pneumonia, but if it just says natural causes on a death certificate, and that's the only data you have, it's not really gonna tell you a whole lot. So that's just one example, but sometimes diseases are recorded incorrectly, things like that. So you're subject to those flaws. Now, having said all that, they are incredibly useful. Their usefulness is limited. You can't say one thing causes something else because there's all those factors, but they are incredibly useful and very reasonable compared to experiments. So some types of experiments have too many factors to reasonably be able to control. So, I mean, you can imagine things like if you're trying to set up experiments for certain things, there's just way too many variables that you can't possibly control in the real world. And here's one example. If you're investigating the effects of socioeconomic status, you can't, first of all, randomly assign someone to being, poor, wealthy, middle class. You can't randomly assign someone to that. That's their place in life, at least at that point in time. So trying to control other factors associated with being in a particular socioeconomic status, you can't really control that either. So those kinds of reports and studies, and those are all observational studies. Plus, some experiments are unethical. You could observe something unethical happening and report on it, but you would never intentionally cause something unethical to happen. So let's say you withheld a known cure from people just because you set up your experiment this way. They have this disease, but I'm not going to give them the cure because I want to see what happens. That would be just unethical is the least of it right there. I mean, that's criminal. So there are some things we can't do as experiments. So observational studies are really important. All right. So now what we're going to do, we have 8 multiple choice questions. I should actually, before I start talking about that, we're just wrapping up with this part today. I encourage you to go in your, reread that, read the rest of chapter 13 to prepare for Monday. And what we're going to do is I've got 8 multiple choice questions. As soon as we finish all 8 of those, I'll let you know what your homework is, and that is class for the day. So just be ready to answer these. I don't remember if these require, I don't think any require calculations. But here's the first one, and I will launch the poll. You can continue to provide answers as we go over this, but as we look at this, all of these are about stem plots. Stem plots are used for quantitative and categorical. No, that's not true. We only use these for quantitative, so this is not true. Equally useful for small and large data sets. They are not useful for very large data sets. They're very unwieldy that way. They can show symmetry, gaps, clusters, and outliers. Yeah, they can show the shape of the distribution. So this is a good answer. That's probably it. They should be, so stems should be skipped only if there's no data value for a particular stem. So again, that's like if you had 1, 2, and this is like 10, 20, and you don't have any 30s, so you just skip to 4. Well, you never do that because that wouldn't show the data. You need to show gaps. So you never ever skip stems, not that one. And whether or not to provide a key depends on the relative importance. No, you always need to provide a key. So the answer is C here, and that's what about half of you were able to get. So let's look at another one. So there's your next problem. I'll relaunch the poll. So we've got the answers. We got over 13. There are 3 very popular answers. I'm going to start with this one. The regression line explains 86.3% of the variation in cancer deaths among Americans over the years since 2001. So this is talking about R squared, and they're not asking us to interpret that. So, but this isn't even our R squared. This is our correlation. So you'd have to square that. So then maybe if that's where you were going, then you square it, you get your 74.5%. Again, this is actually a correct thing to say, but it's the correct thing to say about, and I shouldn't put right now, it's a correct thing to say about R squared, your coefficient of determination. They're asking about slope, so the correct answer is A. The number of cancer deaths among Americans has been dropping by an average of 6,050 per year since 2001. So you can see they're talking about the rate that it's dropping, and that's in thousands. Negative means it is dropping, and every year. And they said, of course, per year right here. Now, keep in mind, it's since 2001. That's what's mentioned right there. Okay. So there you go. Let's move ahead to the next one. All right, if you got a last minute guess, go ahead and put that in. So let's just kind of break this down. First of all, it's asking which of the following is possible. So it's important to think about just, is it even possible for this situation to be true? And I'm gonna start with the first and the third, because that's what a lot of people are kind of honing in on. So the first and the third one. The first point has larger, okay, well, sorry, before I read that, the correlation is negative. Okay, so the first point has a larger X value and smaller Y value than the second point. So this makes sense from an idea of a negative correlation. So if you got your negative correlation, if you've got your first point down here and your second point up here, well, the first point has a larger X value and smaller Y value. Okay, that fits. The third one has a smaller X value and a larger Y value. So that's right there. That second one, we have to remember, this is a scatter plot. So my dots are very weird looking today, but whatever. So it's a scatter plot. So keep in mind that 2 is also possible. The first point has a larger X value and larger Y value than the second. This is still a negative correlation, but this point right here has a larger X value and Y value than this one. So that is a possible scenario. So the correct answer is E, all of them. So there you go. Again, kind of these simple ideas, and you're like, oh, I forgot to think about that. So I bet a lot of you, when you saw the answer, you're like, oh, dang, I should have thought of that. So it's good to kind of think about that stuff now. And let's look at our next problem at this point. No, didn't move forward, sorry. There it is. So we'll just run through these pretty quickly. The empirical rule applies to both sets. Notice that AP, and this is not a specific AP question, but the empirical rule, that 68, 95, 99.7 rule, that only applies to approximately normal sets, which we've got right here, but not right here, which is definitely a skewed distribution. So no, it's not A. The median of each is approximately, you know, the ends of the range divided by 2. That is approximately true for A, because it's approximately normal, but that is not true for B. Of course, you'd never want to guess the median this way, but it is approximately true for A only. C, the mean and median should be about the same for one of them. That's true here. And the mean should be less than the median in another, and that is true right here. Here's your mean, and your median would be a little bit higher, somewhere over here. So there you go. And this is lower as you move up. So yeah, the mean is lower. Good on that one. The ranges of the two sets are equal. Now, if you only look at the stems, that might seem true. So you have to compare. This is 121 to 176. This goes 127 up to 178. So those ranges are not the same. They're close. And the variance of the two sets are approximately the same. The variance depends on your standard deviation equation. You just square that, and we can see because this has outliers, our standard deviation is going to be thrown off on that one. Okay, so that one's not true. So there we go. C is the correct answer, which is what most of you thought. All right, let's look at those. So the first four were from previous units. Now we're going to talk about the current stuff. So pretty simple situation here. Survey her client base. She's got 47 business cards. She can randomly pull those cards from a hat. That is just a simple random sample. She didn't separate them in any way. And the population is, it says right here, she wants to survey her client base. So that's her population. So it's fair and nothing fishy going on with that. Okay, so let's look at the next one. So this one's a little hard to read, I apologize, but hopefully you can figure it out. Okay, so the newspaper advice columnist asked readers to respond to a question on whether they'd remarry their current spouse. 25,000 responses, 80% said no. This was actually got a very even spread among all 5 answers. So let's just start at the bottom. This was a legitimate sample. Well, I'm going to spoil it for you. No, it was not a legitimate sample. So we have to think of who the population is. And the population, without getting any other information, is probably trying to say this is true of the population at large, whatever, we'll assume the United States. The survey would have been more meaningful if it used a control group. That's not the problem here. Survey would have been more meaningful if she had picked a random sample of 25,000, within those 25,000. No, the sample itself was flawed to begin with. No meaningful conclusion is possible without knowing something more about the characteristics of the reader. And that's a thing, this is actually a key thing to talk about, because with random sampling, we don't need to know anything about the people who are selected. The idea is if we're randomly sampling, we're going to get a cross-section of the population. Basically, the answer is A. This is meaningless. It's a voluntary response bias. Only the people who are feel very strongly about it are responding, and 80% of them said they wouldn't remarry. Wow, I don't know what to think about that. But anyways, it is voluntary response. It is not a legit sample that we can use for anything. All right. Next question. We are 0 for 16. I gotta say, that's okay. Better to have everyone miss this problem now. Ooh, 0 for 17 now. All right, let's think about this. We got 30 baseball teams with a 40-person roster. Sample of 60 players is to be randomly selected to undergo drug tests. Now each team is going to draw 2 names randomly. Will this be a simple random sample? The most common answer given is A. And of course, it's not right. I should cross that out. It's not a simple random sample. It is true that every player has the same chance of being selected, but that's not what defines a simple random sample. What defines a simple random sample is that each sample has the same chance of being selected. So in a pure, simple random sample, we've got 30 teams. I'm only going to draw. So these circles represent teams. I'll just draw 3 of them. And we're drawing 2 per team. This is stratified. All right. But in a true random sample, you could have 5 players from this team drawn. And what this is prohibiting or limiting from happening is that you're only going to get 2 from each team with the way the sample is set up. So it is not every single sample has equal chance of being selected. So that is a key idea, and hopefully this question helps to drive it home. All right. So any questions on that one? Okay. Hopefully that was clear enough in the explanation. Last question of the day. Okay, so if you're about to put your answer in, go for it. We've got, I'll tell you, by far the most common answer here is E, all of the cases. So we talked about sampling error yesterday. It's the very last thing that we did. So let's just go through these. Sampling error occurs when interviewers make mistakes resulting in bias. It's not that one. Okay, so that means it's not going to be all cases. Interviewers use judgment instead of random choice in picking the sample. No. So keep in mind what a lot of you are thinking is that sampling error is bias, and it's not. Okay, so bias can happen when this happens, when this happens, when samples are too small, you can have bias, or just inaccurate results at least. And it's this last one, or D, not the last one. So sampling error occurs when you take a sample, you are calculating a statistic that's going to estimate what the true population parameter is. It is not going to be exact. And whatever difference there is between the sample statistic and the exact population parameter is your sampling error. The key thing about this is that sampling error cannot be avoided. It's a natural part of sampling, and it's, I mean, for all intents and purposes, it's fine. We just need to know that it's not a sign of bias or bad sample design. Okay, so the correct answer is D right here. All right. So hopefully that clarifies. Now these last 2, I know a lot of people missed them. I'm not trying to make you guys feel bad by missing them. I picked these questions specifically because I wanted to make sure that we talked about these kind of subtle distinctions, especially that last one with the simple random sample and here. So it's really good to kind of get those points reinforced. Okay, so let me clear this. If any of this was confusing for you, you can hang out after we're done in a minute, and you can get some help with that. But let's just finish up here. Read chapter 13. I know that was last night's homework, but if you didn't do all of it, we only covered like the first 3 or 4 pages today. Complete the Unit 2 progress check. If you go check for the homework tonight, I added a new progress check into your AP classroom. So that's another reason you need to get signed up. So work on that. Work on Unit 1 progress check if you haven't done that. And anyways, come back on Monday prepared to do the rest of chapter 13. So it'll be a busy Monday, but you got the weekend to prepare. All right, having said all that, have a wonderful weekend, and finish in just over 40 minutes.
Have a good weekend, Mr. Davis.
See ya.
All right, bye guys. All right, bye. Welcome.